Alright, so for this last recording in our workshop on geomorphology, we're going to briefly discuss Aeolian or wind-driven landforms and processes. So, like water, wind is a fluid, so a lot of the same concepts associated with fluvial erosion and fluvial landforms and flowing water things apply to wind as well. So things like the Holstrom curve, that general concept of you need a faster wind speed to pick up larger particles, that applies here. However, wind is a lot less dense per water, so it has a lot more trouble carrying particles. So the particles that tend to get moved by wind are a lot finer than the ones you could move with water. So you're not moving any big, pebbles or boulders or anything with wind in normal circumstances. There are two main Aeolian erosional processes to discuss. The first is called deflation, and that simply means the wind removing or blowing away the sand from an area. And then the second is abrasion, where now that the wind has that sand entrained, it sort of sandblasts, for lack of a better word, another surface to carve out larger rocks with the smaller particles of sand. So when we're talking about deflation, the main example is desert pavement, which is a landscape like this where all of the finer sand-sized particles have been blown away, leaving behind a landscape full of larger stones that the wind can't pick up. Now below these stones might be more fine sand that is being protected by an armor layer of stones, but this is desert pavement. And this is actually a quite common landscape. Only around 20% of the world's deserts are actually sandy. A lot of other deserts, remember, desert's a climate term that describes an area that doesn't get much rainfall. So a lot of the world's deserts look a lot like this. And then when we're talking about abrasion, a good example is these rocks called ventifacts, which refers to a sandblasted rock. And wind, because it struggles to pick up particles, it only picks them up to a certain height. So you can see that nearer to the ground surface, there's been a lot of sandblasting, but beyond a certain critical height here, the rock hasn't been sandblasted as much. So what you often get is these larger rocks and then a thinner column that's been sandblasted more, and eventually the thin column can't support the larger mass on top, and it ends up like this one, and then the larger mass is now in range of the sand and gets blasted away. Another example is yardangs, which are these linear features, perhaps controlled by bedrock structures, where sandblasting has taken place and helped shape them. And actually, some people think that the Sphinx in Egypt was carved from one of these yardangs. So that's Aeolian erosion. And in terms of Aeolian deposition, we get dunes. And dunes occur in water flows as well, but when people think of dunes, they often think of Aeolian processes. And anytime you have a dune, dunes come in a variety of shapes and sizes, but most dunes have a windward slope and a leeward slope. And the windward slope, it's always shallower than the leeward slope. It's because the sand will bounce up and up and up and up and up the windward slope until it reaches sort of a critical height where it can't support itself anymore, and then it'll fall down the leeward slope, which will be a lot steeper. So when you look at a dune, you always know where the prevailing wind is coming from, It'll come from the side with the shallower slope and go towards the side, the lee side with the steeper slope. And as I said, there are a variety of dune forms. There's Barchan dunes, transverse, hybrids, linear dunes, parabolic dunes. But all of these examples here, their steep side is downwind, their shallow side is upwind. So if you want to infer wind direction from dunes, look at the steepness of the two sides. The shape doesn't quite matter as much. The one sort of example where this is not the case is star dunes, and these are formed when you have a variety of prevailing wind directions. So they don't have as clear of a windward and leeward side. So here's a discussion question for you to consider. Where on Earth do Aeolian processes operate? Do they only operate in, certain deserts, or do they operate everywhere? And the answer is they operate wherever there is wind, and obviously the more wind, the stronger the Aeolian process. But as with any landscape, you have multiple processes going on at any given time, whether those be Aeolian or fluvial or mass wasting processes or glacial processes or all sorts of other types. And in certain landscapes, some processes are dominant, and in others are dominant. And because water is so much stronger than wind, it's a stronger agent of erosion, it's able to move more and bigger stuff. Quite often, in a lot of landscapes, water is the dominant agent of erosion, including some desert landscapes that are occasionally flooded. So that is why we associate a lot of arid regions with Aeolian processes, because there's a lot less water available, so you actually get to see the consequences of the wind. But wind acts everywhere. I was on the beach a bit ago, and there was lots of sand being blown at me. So Aeolian processes and transport act wherever there is wind. And while people think about the Sahara when they think about dunes, we have lots of dunes here in Canada. On the left-hand side here is the Athabasca dune system. I believe this is in Saskatchewan. And it's an absolutely stunning dune system that was formed near the end of the last glaciation and is still active today. And on the right here, we actually have the Carcross Desert in the Yukon, which was stabilized by vegetation until human activities such as Stephen Harper here ATVing, disrupted the dune system and sort of reactivated it. So that is it for Aeolian processes, and with that brings workshop 5 to a close.